Okay, guys, so this is just a quick review of the calculations that you're going to need to be successful on your exam, particularly for your free response portion. So we know that one is worth like 15% of your total exam score. And so I want to make sure that everybody is totally familiar with all of the calculations for percent abundance and then calculating your average atomic mass. All right, so it says that we have discovered an element with an atomic number of 119, and we named it MnM. We want to find the average atomic mass, so we collect the following data. So this is in your table. So basically, like if you think back on the lab, this is the same as saying like I had 17 mini M&Ms, I had 10 plain M&Ms, I had 4 caramel M&Ms. So that's kind of what it was like when we were doing it in class. So the first thing that we need to do here, it says to calculate the percent abundance for each one. Okay, so we need to divide the part by the whole times 100. All right, so it's part over whole times 100. It's just taking a percentage. It's saying what percentage of MnM 297 is there compared to all of the atoms of MnM. So the first one says, let's just label our information here. All right, so for that one, it said we had 17. Okay, so 17 divided by 31 times 100. That's going to be our calculation. The next one, the next one is 10 divided by 31 times 100. That is our calculation for that one. And this one will be MnM 299. And that one was 4 divided by 31 times 100. All right, so we'll go ahead and just do these. So 17 divided by 31 times 100. And it says to round to the whole number. It says round your answer to a whole number and put your answer in the box. Okay, so if we were to round this answer, then we would have 55%. 55%. All right, so now we're going to do 10 divided by 31 times 100. And that one is, if we're rounding down to 32%, looks good. And then this one is, let's see, 4 divided by 31 times 100. And this one will round to 13%. Okay. All right, so that part is done. And the next thing it's asking us to do, it says write the nuclear notation for the most abundant neutral isotope of MnM. So the one that has the highest abundance, it's the MnM 297. And so we know that that 297, that's going to be the mass number. So we would start with our symbol. All right, it's for the nuclear notation. And we would write 297 up here. And then we're going to want to write our atomic number. Okay, that was given to us in the beginning. It's 119. And so that's it, because it says we're neutral. All right, so if we're neutral, that means that we have no charge to indicate here. Our protons and our electrons have to be the same number. All right, so that means we're neutral. All right, and then finally, it wants us to calculate the average atomic mass of MnM. And so this is what we'll do. This is our formula. All right, we'll just say mass times percent abundance plus mass times percent abundance. Okay, it'll have to be percent abund. Ran out of room. Okay, we would just keep doing that for each one that we have, each isotope. So in this particular case, we have 3 isotopes that we're looking at. And so we're going to have 3 separate multiplications, and then we're going to add our answers all together at the end. Okay, so for this first one, let me just label here. All right, we have this one, 297, that's our mass number. And then 298, and then 299. So these are the mass numbers that we're going to use. We're going to multiply by the percent abundance for each. So this one was 55%. All right, but I'm using the decimal form just to make this a little bit more clear. All right, so that's going to be my first one. And then I'm going to multiply by 32%. So it's 0.32. And then finally 13%. So remember, like when you're using the decimal form, you can either divide by 100 to take it out of that percent, or you can just move your decimal place over two places to the left. So you'll get the same result either way. Okay. And then now we'll just do our calculations here. 297 times 0.55, 163.35, and then 298 times 0.32, 95.36, and then 299 times 0.13, 38.87. Okay, so this number plus 95.36 plus 16, how do I delete? There we go. 163.35. And our answer is 297.58 AMU, atomic mass units. Okay. All right, so this is our answer. And, if you get some answer that is either higher than your highest number or lower than your lowest number, you have to redo it because that cannot be. So, generally speaking, especially if you have one isotope that's really in high abundance, your answer is usually closest to that number, but it really kind of just depends. In this particular case, let's see, is it going to work out that way? It's about two, yeah, 297.58. Yeah, I mean, in this particular case, it's actually a little closer to 298. But usually if you have only two of them, then you definitely will have it closer. Like, let's say you only had two isotopes, then your answer, should be closer on a number line to the one that's the most abundant. But we have three here, so it's a little bit more complicated. But in any case, your number must be in between that low number and the high number for your mass numbers. And then you're probably on track. All right, I hope this was helpful. Good luck on your test. Thanks.